Shift and Podcast. Hi, everybody. We have a special guest today, Michael Feathers, who, in my opinion, is the author of one of the best books about software engineering and programming, working effectively with legacy code. And Michael, say a few words about yourself, please.
Sure. Yeah. So I'm Michael Feathers. Wrote the book Working Effectively with Legacy Code. Have a long history of work in the field. Got involved in the Agile movement in the 1990s before it even had a name, and have spent a lot of time basically going and helping organizations. Just basically improve the way that they write code, right? And a lot of time also basically thinking about the problem of how does code go bad, because it's something we deal with all the time, and it's you can't really be at the end point of that particular problem dealing with legacy code without wondering about how you actually get there and how you basically make sure that that doesn't happen in the future. So that's pretty much my area of emphasis.
So you wrote that book quite a long time ago. And my first question for you, if you compare the time when you were writing the book and the time we have right now, do you think the code is better now in general, the code you face, the code you meet, the projects you see, or it's getting worse, or it's the same?
I think there's two answers to this. I think open source is a lot better than it was in the past. And I think, there is that thing where when you have more eyes on something, it becomes, much better because people are kind of like maybe embarrassed a little bit to go and do the bad thing, right? So they tend to do the better thing. I still do notice that in many companies, they basically are dealing with almost like mountains of code from like maybe 20, 30 years ago. And once things kind of get to a particular point, it's hard to go and make a dramatic shift and make things much better. So, I'll still basically see, people have like 15 levels of indentation, in their code and things along those lines. They're just really rough. I would add to this though, that I think that basically the people entering the field are basically getting better examples of good practice these days. And that's good. So I think a lot of the coding styles that led to some severe problems in the past are kind of not quite as common these days. So it's good.
And the amount of legacy code is growing, as far as I understand.
Well, it's a growth industry, It's like when you think about, but there is this thing too, because I think that one of the perspectives that some people have upon software development is that if everybody just basically maintains their diligence, things are going to basically be good, and you have to be the best you can as a software developer. And I think those things are true, but it takes a lot of diligence to basically keep that level of effort to the point where things stay good. A thing that we have to recognize is that code in a very natural way does tend to kind of go bad. And one of the things I kind of use as a way of explaining this is kind of like the notion of in behavioral economics, okay, for instance, there's this entire science which is around discovering how people make decisions and what incentives do to decision making. And I think you can carry this all the way down to the code level. If it's easier to add code to an existing method, then chances are you're going to do that instead of adding a new method. And if it's easier to go and add a method to an existing class, chances are you're going to go and do that rather than create a new class. So I think the incentives are set up in such a way where things just tend to get bigger over time. And then as they get bigger over time, they get harder to understand. And as they get harder to understand, then you're in this state where you just have legacy code, right? So it takes constant diligence to go and deal with these things, but it is almost like a trajectory that a lot of systems kind of carry. They essentially start to go and get to this less ideal state over time. So.
And you think open source, which you mentioned earlier, helps us in this, in reducing the amount of these troubles, legacy, or?
I can only speak from experience that basically when I'm training, quite often I look for good examples I can use in training. So I'll try to go and mine open source. And, quite often I give up in frustration, and I basically write my own examples based upon bad things I've seen. But it really seems to be hard to find things in open source that I see typically in proprietary code bases. So I think there's something to that in a way.
I mean, bad things or good things? What do you mean by these things?
Bad things, just things that just have gotten way, way out of control,
And why they don't happen in open source?
I suspect it's basically because people take the initiative to go and fix things a bit, or they just feel, I don't know. I think it's an interesting thing about open source because some people are paid to go and do some open source work and stuff like that, but a lot of it is a labor of love in a way, as opposed to, you know, this thing of like, this is a paycheck and I'm basically making the change and don't know if I'm going to be at this job for the next 2 years or not, that kind of thing, you know? So I think things can deteriorate far more under that regime, I guess.
But we still have a lot of companies who keep their code proprietary and they're not planning to make it open source. And
Yeah,
you
and
think it
then
will change?
I'm not really offering a solution that way, in a way. It's just like, it's an observation, you know, that tends to be the case. And there are many things that simply can't become open source just because of, you know, very secrecy things and stuff along those lines. But yeah, and that's not to say that things are uniformly bad in proprietary source code either. They aren't. I just basically know that I routinely get confronted by things that are just really pretty bad. Of course, the thing is, I think there's a bit of selection bias to this too, because you only call me in when things are bad, right? So that's what it comes down to. Yeah.
And when they call you and things are bad, and you see those bad things and you identify them and you tell them about that,
Yeah.
I think they treat you like a bad guy. I mean, programmers who wrote those things. So
Well, I mean, I guess again, it turns into selection bias, because I think the only reason I'm there is because somebody convinced somebody to go and bring me in, right? And then usually that conversation has kind of happened within the organization already, that everybody kind of knows that this is a problem, and you know, maybe the people that are responsible are still there, or maybe they're not, but it doesn't seem like it's anything I really confront all that much directly. Um, yeah, I can imagine a situation where somebody would bring me in and say, okay, you need to tell this person they're writing bad code, but that hasn't really been my experience. So, yeah.
because I was going to ask you the question about this, but now we're just leading to this question that the code is written by people. So in any way, when we blame the code, we kind of blame the author of the code, but people don't like to be blamed. So how do you draw the line between blaming the product and stop at some point and don't blame the author? Or maybe you think we should blame the author.
I think, I don't think we should blame the author. I think that the thing is that, wow, this is a deep subject, because I think it has to do with culture in a way. To me, an ideal culture is where, I can tell you something that happened with some people I worked with about 20 years ago. It's kind of like, we had this little phrase that we would use, you know, it's like, love you like a friend, but this thing you just did, right? It's kind of like that, you know, it's like, you're a great person, but you know what, the thing that we just did, there's a better way of doing this. Let's go and do it that way, right? And it's kind of like this thing of going and providing some kind of distance between the people and the thing that they do, the work product, right? Because in essence, you know, even though we have this felt sense sometimes that a criticism of the work that we do is a criticism of ourselves, you know, that's really counterproductive. You know, it's something that it's worth going and severing that tie to a degree so that we can get better, right? And you know, when you think about it, it's kind of like a fragile state that you can be in, where basically you see your value as solely the thing that you are kind of doing. And if you are in that state, I guess the best thing you can do is go and recognize that with the help of your coworkers, you can make things better. And that basically, sure, you know, you can admit that things aren't all that great now, but there's tomorrow, right? You can get better at doing these particular things, and we all get better together doing these things. But I think having that very direct conversation about these things in teams can be kind of useful. It's rough for us in the industry because at least for many teams, you know, I work with, you know, there is a particular type of person that becomes a programmer or a developer. Quite often we're very reflective, we care about the work that we're doing, and we're also not very confrontational in a way, right? But I think, you know, improvement requires a degree of kind of compassionate confrontation.
Because I've seen situations where people are in the same team. There could be classified in a number of categories, and there is one category of people who really care about the technical debt they leave in the code, and they don't try to, and they try to avoid, like you just mentioned, extending one class, and they try to create new classes, even though it costs them more maybe to do some extra work. But there are other category of people who, like you said, they work from paycheck to paycheck, and they don't really feel passionate about the code they work with. So they just put the new method into the large class and call it a day. So when you come to the team, you definitely see these different types of people. I'm sure about that. So, so probably for you, it is a problem how to address your message properly to the first category or to the second one. So,
Yeah, it is. And the thing is, and I think the hardest part with that is going and basically telling the people in the first category not to offend the people in the second category, right? And this, I used to see this all the time in the industry. You'd have somebody who basically will perhaps go to a conference, for instance, and learn something new and be very excited about it. And then they go back and their excitement kind of like alienates the people that they work with, because it's kind of like, for them, it's not quite as important as it is to you when you're excited about it. And you can definitely work against yourself by being too zealous, too enthusiastic about new ways of doing things. But I think the broader issue is really more an issue of culture, and culture is quite often bigger than just a team issue. If you're developing a culture within the company, where people are looking for better ways to do things, and it's understood that that's a value within the organization, then that makes things a bit better. It shouldn't be something where people say, this is good enough, right? And if you're constantly in the good enough state, then there's an easy place for people to rest that don't want to try a little bit more, right? So yeah, I think there's an issue around that. And for me, then quite often it's a matter of talking to leadership a bit more about how to kind of foster that type of culture, because incentives matter quite often and things along those lines. So.
What do you think about metrics, which some people put on top of code, like good
Yeah.
code, good design? I don't know, many different metrics. So do you think they're useless or useful?
I think they're useful, but there's something called Goodhart's law, which is kind of like, I'm going to kind of botch this in saying it, but it's kind of like pointing out that essentially when you turn something into a metric, then you're going to get more of it, and you may not get more of it in the way that you care to, right? So it can be kind of dangerous in a way. One of the, an early experience I had in the industry was going and visiting a team and seeing that their code didn't make very much sense to me. And it's like their methods were kind of short, and kind of, seemed like it wasn't like, having terrible, gigantic structures, but the names didn't really match the method bodies all that much and stuff like this. And I walked into another part of the room and saw they had like the team rules written up on a wall. And one of them was basically methods should never be longer than 15 lines. And so you can kind of understand exactly what happened with this. Essentially, when they made that the goal and made that more important than understandability, of course, things are going to end up being kind of messed up in a particular way. So how do you get around this? I mean, the way you get around this is to go and make sure that, well, there's two ways. One is to go and basically have a bunch of metrics and talk about them. And then nobody's going to concentrate on any single one of them, right? Another way is to basically sort of like highlight metrics, only temporarily. It's like say, hey, let's go and pay attention to what's going on with, with cohesion in this area of the system and that sort of thing. And then just drop the subject after a couple of months of going and concentrating on it, right? It's a cultural thing as well. It's like how much importance you place upon these particular things. The worst situations are ones where you have a metric in place and the team feels that the only way it can get attention is to go in and move that particular metric, and they'll do what it takes to move the metric. But the side effects quite often can be disastrous, kind of like in the case of that method size thing. I've seen that kind of thing happen with coverage a number of times. It's like, okay, want everybody to improve coverage by 5% every quarter, right? And then you see people improve coverage, but quite often it's in ways that are counterproductive, right? So yeah, it's useful to go and basically see metrics, put them in context, make sure they're not considered too important, have many metrics, highlight them only temporarily. Story I tell about this is like, imagine you have some serious illness and you go to the hospital. They're not going to do just one test to basically go ahead and tell what to do. They'll do several tests, and you want to go and have a multi-dimensional view of what's going on in the code base. And then you can talk about what you want to go and do about it. It's never about just moving one metric,
It's a very interesting metaphor with the hospital, the patient.
Yeah.
I have a team. Also wanted to ask you about this. I have a team which I know how they work, and they write pretty good code. And I talked to their team leader, and I asked them just a few months ago. I asked them whether you use any code style, or do you check the code style? And he told me that I believe that this is a very wrong idea to force different programmers to use the same code style. They just have to be free to write the way they want to write, and they just commit the code to our repository. We just do the pull request review and whatever peer review, and then we accept it. So that he was not saying that we don't have time. Sometimes people say that we don't have time for style checking, whatever. He just said, I truly believe that every programmer has to have the ability, the freedom to write the code the way they want. So what do you think about this?
Well, permit me to be a little bit funny with this, but one thing I might say is that maybe after work you can do oil paintings or something like this. You know, basically if you want to basically do something which is to express your creativity, you know, it's kind of like there are certain constraints when we are working together to make a product, right? And one of the things that does have a high degree of value is to basically have the code oriented in such a way that everybody can kind of understand it and have a shared way of going and doing things. And that's just what cohesion means for a product, right? Yeah, I mean, to express your individuality is a good thing, but expressing it in a way which kind of gets in the way of that communication can be kind of problematic in a way, right? I mean, I think for all of us, it's kind of like, you know, it's great to be creative. It's great to express yourself. There are so many avenues in life to do this. And there do have to be some constraints within a work situation around this. Because the thing that's important with this to remember is that if, let's say you and I are working on a project and I decide that I read a book, here's a different way of doing things. I want to move in this particular direction. It's great when basically you walk into my code and you don't understand and you can ask me, right? Why did you do things this way? It's not so good when it's 10 years from now and basically I'm gone, right? And nobody can ask me why I did this particular thing. It's, you know, we have this thing of, we are constantly generating knowledge when we're basically building up a code base. When some of us leave, the knowledge goes away. And then the question is, how well can the things that remain stand for themselves, you know? And the code is one of the things that is left standing in this, and it has to be understandable, and it has to be something which is suitable for anybody to walk into, you know, of a certain degree of skill and maintain and do their work in. So those are the constraints on our creativity. And I think it's good for us to be very aware of that. And, you know, I do things sometimes, creative things in code that I would never do in production code just for fun, just to learn. But that's a different space than the stuff that we work on together. So,
yeah. Which languages do you use, by the way? Programming language.
Which one? I'm kind of, you know, I'm not programming as much as I used to. I keep going back to Ruby though, and just, you know, for kind of like for my toy programming, if I want to go and explore a concept, because it's relatively easy to do both OO and functional programming, or mutate the language into anything you want it to be, to go and explore an idea or do things along those lines. So little utility programs, I'll do things like that. But for the most part, I'm, you know, in engaging with clients, I'll basically do some refactoring with them in the context of whatever language they're using, and I concentrate on that as opposed to spending much time myself writing new code these days.
Do you think, by the way, that there are languages which are better in terms of quality of code they produce, and some languages are maybe worse?
I think that basically the skill and the conscientiousness with which developers approach their work makes all those differences kind of go away in a way. I've seen people do extremely good work in C, even though people might say that they should be using Rust now or something like this. I think even the divide between dynamic and static languages is not as important as people think it is. It really comes down to people being very careful and conscientious and wanting to do a good job and being skilled at it. Those make a big difference with us. I think the big issue with a lot of languages is really the ergonomics. It's kind of like some people, they prefer dynamic languages because of the flexibility that they're given, and others really want the extra surety that static gives them. And I think that's a choice that just about any organization can make around these things. There's research around, I forget where this is, just that bug rates tend to be roughly the same for static and dynamically typed languages, but change tends to be easier in statically typed languages as code bases grow, you know, as they become much bigger. So if you have an idea of, you know, what your maximum size is going to be or where your code base is going to sit as it reaches maturity, you might have a decent way of going in and sort of dealing with that. So, yeah.
So it's not the language, it's the programmer who is.
Yeah, definitely. And, you know, I do have a controversial opinion about this, which I think is kind of funny in a way. The first language I learned was C, and I taught myself C because I heard it was a hard programming language. I was a math major, and I thought, oh, let's see if I can actually do this, right? So I taught myself C from scratch by myself. And I went to university, and they were teaching me Pascal, which was a teaching language. And I was so shocked because it seemed like there were many things you couldn't do. And I also remember sitting next to someone in a lab, and she was doing her assignment. I looked over at her, and she had an array subscript out of bounds error coming up on her screen. And I'd been programming in Pascal for like a couple of weeks at that point and had never seen that error. And I realized that basically working in C, it's like, if you get that wrong, you're really in serious trouble. So you just learn not to get that wrong, right? But she had this thing which was helping her, and then she could basically relax a bit knowing that it would help her. So I think there is this thing that happens where some technologies force us to be a bit more careful, and it may be more painful, and maybe the risk of error is higher, but from a skill building point of view, I think they're kind of useful to go and have that kind of an unforgiving thing. It makes us a little bit stronger in a way. And then I think it's a completely different issue then when you get down to production code, what can you count on, and things like this. So
interesting. I want to get back to the question about the code ownership and this bus factor, which you mentioned. When we need to understand, as you said, we need to understand that none of us is permanently with the project. So we may go to different projects. But when my personal experience, when I talk to programmers sometimes, and when I mention it to them, in most cases, they get a little bit offended when I sit next to the programmer and say, you know what, probably in the next year or maybe later, you will be gone from this project. And let's think about what's going to happen with your code. They just look at me with not really friendly eyes, because I'm telling them that basically I potentially may replace them, but they don't like to feel like that. They like to feel like owners of the code. And
no, it is a weird thing. I think there's lots of things people just don't like to think about, right? And that's fair, but it's like it's yeah, but I mean, maybe framing the conversation of like, look, you're building something that's going to live beyond you, and it's kind of like you can even stretch it out. I think I've seen many code bases that are like 30 years old, right? And it's kind of like, really, it's like past your retirement age. Even if you choose not to leave early, it's like, if we're doing a good job with this, people will be going in, dealing with us and working with it. And I think it's it's pretty important. I think the other avenue of conversation around this is to point out that it's like, you may forget, it's like maybe you're here in 5 years, but you won't remember exactly why you did this particular thing. Why don't you write it for a beginner? Because that beginner might be you in 5 years,
So you think that code ownership is a false idea?
Well, false idea. I tend to look at things in like, how can I say? I think it's not a thing that we should attempt to basically, have. People are going to feel ownership of what they do, but it's something that we have to kind of work against at times. One of my early experiences in the industry, I was working with a coworker who was actually developing an IDE, believe it or not, inside the research lab of the company I worked at. And it was really interesting because the work that he was doing, the project he was working on by himself, he fully owned this thing, was canceled. And it's like the guy actually felt like leaving the industry and basically going and giving up programming entirely because he spent all this time working on this thing. And the company decided it didn't really need it. The project was canceled. And it's a one-person project. And I just, I said to myself, I knew him pretty well, but, I talked to him and I saw how much despair he had about this. And I said to myself, okay, the lesson here is love what you do, not what you make. It's kind of like the things that you make, somebody can take that away from you, or it can disappear or something like this. But if you love the process of what you're doing, okay, then you're in a better, more robust situation as a developer. So
that's really good advice. What do you think about the future direction which the industry is trying to move now, when some people believe, and actually they have experiments, that instead of programmers, there will be computers writing code, AI, ML, whatever.
But yeah, I think, for as long as the industry has been around, there basically have been people who basically create code generators, templating engines and stuff along those lines. And, it's good. I think the thing that's important for everybody who uses something like this is to understand what source is, what source code happens to be, right? if something is generating code for you and you have to basically maintain the thing that's generated, you really need to be able to understand it, and you need to be able to go and sort of be able to make changes to it independently of the tool that generated it, right? And I think that's one thing that quite often people get wrong when they move into this technology space, is they just think, oh, somebody's gonna press a button, generate a thing, then people go ahead and go and use it, and then that's fine. But the thing that's produced has to be a new starting point where you can work with it, and you don't have to go and regenerate it. If you do, then you end up in a bit of a trap with things, and it shuts down possibilities rather than enhancing them. But it's weird for me being an older person in the industry, because like before I got into the industry back in the 1980s, believe it or not, a friend of mine when I was at college said, Michael, why are you studying computer science? In a couple of years, they'll have written all the programs that people need, and there'll be no need for more programs. And this is a guy who was a business major. And he was a pretty smart guy. And I sat there for about a month or so and thought, God, maybe he's right. Maybe it's kind of like, and from the vantage point of the 1980s, everything was desktop, and it was like, yeah, maybe he's right. And then over and over again across my career, it's kind of like all these signs of gloom and doom, about the things that are going to automate away programming. They come in cycles, but it's just never really true. The important thing to recognize is that human need and desire things is always going to exceed the ability of our existing automation, and then that's going to fuel automation. And even when you have automation producing automation, I'm sure that we'll find ways that we want to go and kind of steer that, which is going to be labor intensive for us. And whatever we're doing in that space, I think I'll call programming.
But they claim that computers will actually express some sort of creativity. So the computer will look at the description of the problem and then think, and then write you the code which solves the problem.
Yeah, I mean, they'll express creativity, but then we have to decide which creativity we actually care about, right? It's kind of like, I mean, so there are things that will be automated away, totally. And that's happened all the way across the industry, but there always seems to be like a next frontier of things that we can't really automate away. And I think the other thing to go and recognize around this is that, gosh, I don't even know how to refer to this, but there is this general thing where some work becomes more commodified, or it becomes more like automatable, but then it's kind of like there's always the higher end work as well. So it's kind of like you're always going to have that kind of thing. I guess one way of looking at this is like restaurants. You have the person at the airport that sells you hot dogs and cooks them in the vat of water and puts them in the bun and sells you that. And then you have a 4-star Michelin chef that basically spends hours and hours designing the menu and creating the meal. And that higher end work, we shift as we automate things, then we basically also open up more space for the higher end things to happen as well, because there's always going to be a desire to go and create more. I think, that's my theory, and maybe I'm wrong about this, but I can only go based upon what I've seen.
What I feel now, because I also write code for quite a few decades, I feel that now writing code is a cheaper activity, more easier activity than it was 20 years ago. So now to create something, you don't need to have a PhD. You don't need to actually study the 5 years in the university. You need basically a book and maybe 2 days of study, and then you go write JavaScript code and it works. So now it's much cheaper. Like you said, we commoditize the profession, the job.
Yeah.
So, and it seems that it still continues. The trend goes up and up. So we have faster and better tools which allow people to write code. So don't you think that it's a threat to maintainability of all this mess people create?
Yeah, there is. And I think, it's funny about this, because when I heard you describe that problem, the first thing I kind of leapt to in my mind was this thing that we don't do a good job of killing off old systems in a way, right? It's kind of like, if we're making it easier and easier for people to go and create new systems, it's actually kind of problematic in a way that we keep around older systems that we could rewrite and replace. And the thing that's rough about this is that things can get so complex that you can't really rewrite or replace them very easily. So it's better to do that before they become terribly complex. Yeah, I think one of the things I keep coming back to with systems development is that it's always like biology in a way. It's kind of like the thing I was telling you earlier about how a method grows and grows and grows, and a class grows and grows and grows. That's like biological growth. And the thing that software can't do by itself is actually selectively kill off pieces, right? Like the cells in your body will die, like billions of cells in your body die every day and they get regenerated. And we don't do that. We don't have an easy process of going in, getting rid of old bad code and saying, let's just rewrite this piece, you know? And so then we end up swamped with all this stuff that is, you know, put together very quickly by people reading Stack Overflow. And then, you know, if we're unlucky in a way, that code becomes very valuable and you can't really shut it off, but then you have trouble going and modifying it, right? So it's the cost benefit trade-off is something we need to kind of work on. Systems replacement versus writing new code.
Yeah, because I've heard stories of large companies that they have basically billions of lines of code now, and most of this, like the largest part of the code base, nobody doesn't know how to build, how to, you know, how to package everything. It's just nobody wants to touch it, because if you touch something, you may not be able to package it together anymore, and that's going to be a disaster.
This is equivalently like a person who's 110 years old on life support in the hospital, and everybody is scared to breathe around them because things could go wrong and they could die, right?
Right.
And, you know, and I hate to be, I don't want to be grim about this, but biology has the solution, which is really that, you know, basically organisms die over time and new ones replace them. And the same thing happens in the business cycle, that quite often you'll get to the point where you have a system which is so terrible that nobody knows how to modify it. And then there's simply things that the organization can't do to compete any longer because change is too cost prohibitive. And then you end up having newer companies replacing, you know, the older companies sometimes, where the older company decides to go and create another product which is slightly different, but basically can take a new user base forward and things like this. So there are all these strategies around doing this sort of thing, but you know, it's this thing where things become so valuable that you can't really replace them, and we become captured by them to some degree. I think we're always going to have that to some degree. I think it's nice when we're aware of that happening and we can say, maybe this is the time to create a new product, you know, or something, right? I mean, that's a thing to think about.
Don't you think that we as a society have to start thinking about some legal rules about writing code? Because now we have billions of lines of code, and the code becomes more and more part of our life. And if we already regulate, for example, you know, driving cars or paying taxes or medicine, healthcare, but we don't do almost anything in the area of coding. So I can become a programmer, write whatever I want. Nobody's gonna punish me or regulate me for the way I write code. I just write it. I just create this billions lines of code, which may potentially in 20 years ruin our civilization, because like we just explained, we have more and more of this legacy code, which is a dead organism basically. So maybe eventually we're going to have you know, a bigger disaster.
Yeah, I'm trying to remember the name of the author. It might be Steve McConnell or Steve McGuire that wrote a book a long time ago called After the Gold Rush. And the argument that he was making was that essentially we're in a big growth phase for software development. And once that kind of slows down a bit, then people are going to start thinking more about regulating the profession of writing code. But I think the thing that's rough is that it's almost like the genie is out of the bottle and the growth doesn't seem like it's slowing down in any way. And software is so central to not just things which are life and death things and mission critical, but also the typical thing that happens, like putting a website up for a business or something like that, that it seems like it's hard to go and think of a uniform regime of regulation that would cover those two extremes. It's like the same set of rules for the Michelin star chef and the hot dog vendor. I think at some level there are commonalities around these things, but even the line between whether a person is considered a programmer or not, maybe it's just because we're still in the gold rush phase around all this. But I also tend to feel that software development is so pervasive now that the chances of kind of reining it in that way are kind of tough, particularly when you have different areas of different legal systems, even across countries, and all these things. So it's funny. I think your question was more like, should we do this? And
yeah,
often when people approach me with a should question, I ask myself first, is it even possible, right? And for this one, I'm not really sure it's possible, in the near term, that we actually go. A particular country may choose to do this, a particular locality. they're then going to be in competition with others that don't. There's a lot of complex moving parts to that question around this. And I feel a bit sad about this because I really, really want to see people use better practices, but I feel it's much more an organic thing. It's talking to somebody who knows how to do things, figuring out for yourself what works better, and figuring out from people around you how to do things. The other thing I'd add to this is that, at least like in the US, for instance, it's like there are things which are considered engineering, right? And these are things that require sign-offs by professional engineers. And at least my understanding is, I could be wrong about this, that for things that are life and death critical, quite often those are embedded within some kind of an engineering process. And so software has to be checked out in that scheme also. It's just really whether it gets to that point of this is a life or death thing. And then it's like you're going to basically fall under that area of legislation. So it happens to some degree, but it's definitely not uniform, so.
Some people say that productivity, or us trying to achieve productivity, is killing the quality. And for most businesses, productivity or more features, more functionality or performance,
Yeah.
Matters way more than the quality of the code programmers write. Because at the business level, there are not so many people who even understand code or care about the way people write unit tests or the way people name their methods in the class. So that's why they only ask us, for programmers, for productivity. And when we programmers tell them that we would like to write it to make it right, then most probably the business will say, you don't understand what is right. So you need to focus on productivity. So what's your take on productivity as a concept for programmers?
Well, it's kind of funny with this. I think it's an important thing, but I was part of like the entire like agile space, starting in the late 1990s and that sort of thing. And I think one thing is that we kind of like were doing in terms of messaging around this is getting people to think more about reactivity and proactivity than performance, right? So if you are developing something, it's probably way more valuable for you to go and do something quickly, get market response to it, and be able to change your mind and then basically do different things with it, than to basically spend a lot of time concentrating on performance of a longer term task, right? So that kind of thing, it can lead to the same kind of an issue of like, you have things that, say you strike gold, right? You basically go and get something which is working in production, and you have lots of customers tied up where you've got to invest then in what it takes to go and basically make that maintainable over time, right? That is a hard problem, right? But it's not, I think we kept trying to go and frame it in terms of, it's not about getting the solution fast, it's by getting the right solution, right? And there's a lot of things that tend to be covered in that particular space. But like I said, I think it does lead to that thing of like, what do you do about going and making things more maintainable, so that, you can basically preserve that value.
And do you think it's possible to measure the performance of a programmer? Just a question, a little bit, a sidetrack question.
Yeah, measuring performance of a programmer. It's funny. I think that gets down to the metrics thing we talked about a little bit earlier also, right? I think some of these things are really multi-dimensional. I've known developers who can basically just do, solve astounding problems very quickly and write code to go and do those things. And then there's the other dimension of like, can they communicate that to their coworkers and help them understand what the solution is? Is it understandable by their coworkers? Do they get along with their coworkers? Are they able to go and do all these things? So I don't think there's any single metric around this, but I do think there's considerable skill variation across the field. And I think there's also, in addition to that, there's also differences in what people enjoy doing, right? So there's particular skills and things that people enjoy doing. And I was like in a team basically seeing when everybody's kind of like, oh yeah, that's an area you like, so why don't you do that and I'll do this. And people can kind of concentrate on their areas to some degree. Good to be able to do a little bit of everything, but it's also nice to go and have a specialty sometimes. I think that's kind of useful.
I know one company, one startup, and they're trying to build a software which will automatically collect the statistics of the code you write, as for example,
Yeah.
as a programmer, many different things about the way you write code, where you write it, when you
Mhm.
post your comments, when you post your pull requests, different things about you as a programmer. And then
Yeah.
in the end, they will tell your manager, like maybe a collection of metrics, collection of numbers, which will compare you with your fellow sitting next desk.
Yeah, it doesn't sound like a good plan, honestly. I mean, you can do that kind of thing, but it's a weird situation with that too, because if you are basically one person working on a project all by yourself, it's kind of, okay, I guess. But programming is generally social these days. Essentially, we're usually working on things which are bigger than one person, right? And at that point, then you basically have to go and sort of think about how are they getting along with each other, right? And quite often the measures of whether people are going to get along with each other are very different from the measures of like how well they write commit messages and things along those lines, right? So yeah, it doesn't seem like a great thing. And I'll take this opportunity to go and basically mention something else that some organizations are doing. Sometimes called mob programming or ensemble programming, where you have several people working together, kind of like an extension of pair programming, but when you have more like 5 or 6 people working together to go and sort of solve a problem together. There's enough intricacy to software development work that quite often having more than one perspective is very useful. And then how do you actually measure that, right? So I think there's a lot of interesting stuff in that space. I don't come down cleanly on whether measuring people's abilities is uniformly bad, but it can be abused. So.
Yeah, but I think I agree about this, but I'm thinking what will happen, what is happening now, what will happen in the future even more when the amount of programmers will grow, and we will have not 10 millions in the world, right, like we have now, but we're going to have 100 millions in the world, and
Yeah.
the programmer will be not an artist anymore, like most of us now. The programmers
Mhm.
will be just regular, code writers, and
Mhm.
the management, the business will have to make objective decisions about these people writing code, not anymore creating some beautiful stuff, but actually implementing and writing code in a quite traditional and conveyor way. So when you just write and
Yeah.
write and write
Yeah.
and go home. So maybe at that point it will be important to have some sort of metrics which will be possible to put on top of
Yeah, I
us.
mean, people do stuff like that, and I think there's also there's a thing of certifications and things along those lines, right? And the general interview process. I mean, it's a rather sensitive area, but I think again, I'm going to come back to the thing of like things are not going to be uniformly distributed, right? Essentially, there's always going to be the realm which is kind of like more like an artist, I guess, in a way, or basically the person who can kind of walk in and really kind of solve the problem. And that's going to exist at one extreme in the industry, and then you'll have areas where you have companies that are just okay hiring junior people because they know that what they're doing isn't really rocket science, but they basically need people who are earnest and conscientious about what they're doing and can do a very good job, even if they may not be the best programmers in the world, right? So I think they're all across that continuum. There might be different gates for how you actually figure out the person you want in those different kinds of roles. It's going to vary by company, I'm sure.
So let me get back to the more technical level.
Yeah.
If we look at the languages we have now, programming languages, do you see something which you would change if you would be able to just jump into the industry?
It's a great question, because I haven't thought about it in a while. I've kind of had my head a little bit out of code recently. But I think, gosh, I forget who does this now. Is .NET doing this now, where basically it's like immutability by default?
Uh-huh.
I think it would be a tough thing for .NET to pull off, but I'm looking forward to basically programming languages making immutability the default, and it's like that happens in, Clojure and Lisp languages and stuff like that. But for the more mainstream languages, it seems like it's an easy thing to go and do, just change the default. I think that makes a very big difference in terms of how it makes refactoring much easier when you basically are like producing new values all the time rather than mutating existing ones and stuff along those lines. I think that's kind of like the main thing I would care about a lot. The other thing I think is really interesting is I love the idea of the Erlang programming language. And I think, that Joe Armstrong and the team that he had around him developing Erlang were really terribly insightful people, and that it's sort of solved a lot of very interesting problems. It's not a language which is useful for all contexts, but it's something that everybody can learn from. So I look forward to seeing more stuff from there kind of move into programming language design, right? I guess just to go and sort of summarize that very quickly, what goes on in Erlang is it's really trivial to create processes, and processes are these autonomous things that kind of run and they send messages to each other. It's a functional programming language. It's dynamically typed. But the thing is that the libraries that come with it give you the ability to kind of, if there's any kind of a failure, processes die. And then basically there's a set of strategies that they use to go and create replacement processes. So it kind of builds robustness into the language itself, right? So it's kind of like you have to do, there's much less that you have to go and think about in terms of error handling, because it's kind of like the types of glitches that we typically have can be dealt with in a robust way through the design with relative ease compared to most other programming languages. So I'd love to see more of the insights of that kind of move into other programming languages. Quite often right now, it happens at the library or the framework level rather than being integrated in the languages themselves. So yeah, those are the two main things.
Maybe something for the maintainability, maybe not the functionality, but in general, the maintainability.
Yeah, it's an interesting one with that. Yeah, I haven't really thought about that question in a while. Well, let me give you a very radical one, because I think it's, and nobody's going to do this, but I've been joking about this with friends for years, is that I'd love to see a programming language or an environment where basically every line of code that you write is basically deleted 3 months from when you wrote it. Okay. And it's a weird thought experiment with this. And this again, this is something that nobody's going to go and do. But the thing that's kind of interesting about this is, as I was mentioning earlier, nobody really thinks about code death or systems death, right? You learn a lot by rewriting something, right? And it's kind of like if you have to rewrite something consistently, you're going to find better ways and shorter ways of going and doing that particular task, right? And that would always basically keep a system relatively recent if you basically had like a cap on how long a line of code. Of course, there's always going to be like an escape hatch, like I just copied the code to a file and then copy back in or something ridiculous like that. But I think there's kind of like gaming things around some of these things that might be kind of useful for going in sort of like, raising awareness of those kinds of things. I think it was Chuck Moore who wrote the Forth programming language, Forth, right? Has rewritten Forth interpreters his entire life, and he just enjoys rewriting them because he always learns something new in the process of doing these things. I think other areas of programming that I think are underserved are APL, right? It's a very interesting programming language. There's a couple of variants, J and K and Q, but it was developed originally as a mathematical notation, and you can write very precise, short programs that do very powerful things because of the orthogonality of the instructions that kind of get munched together. And a lot of this is kind of like reflected itself in like the pandas libraries and stuff like that for Python. So it's taking a lot of the same ideas, but that language space has always been very interesting to me too. And I think there's a lot that can be kind of discovered there, but people aren't really taking it up as much as they could. So.
What do you think about UML?
UML, it's funny that you mentioned that because I keep coming back to it, periodically, right? So I'm doing architecture work with some teams now, and it's kind of weird because we talk about things in meetings, but I'm like, let me draw a picture, and then I'll draw a picture, and then people will want to see the boxes as classes, but I can say, well, they're really kind of like concepts at this stage. Let's talk about the concepts we have, right? And that's a level of abstraction that quite often I find developers aren't used to dealing with these days, because so much is immediate for us. We can look things up and just do things and write code and get things done. But I think that the abstraction that diagrammatic languages give us is very useful for us to be able to kind of consolidate ideas and consider ideas and trade them off against each other. So I think the thing that was problematic about UML is that they tried to go and basically make it something which could almost like express all the possible semantics of the system. And that's great. But the thing is, it's kind of like, it's just boxes and lines, right? And just moving to boxes and lines in a whiteboard or a Miro or something like that is really great for conversation and basically going and consolidating ideas about things. So I think UML overdid it, and that's one of the reasons why people don't talk about it much. But part of it could be generational. I think it'd be much better if a lot of people today really were seeking better visual representations of their systems to work with.
Why I ask you about UML? Because my next question is, don't you think it would be beneficial for maintainers of the code if we can integrate the design somehow into the code? Because right now, all we have is just classes, 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 and methods, but the design stays in the diagrams, but there's no real
Yeah.
close integration. You know what I'm talking about?
Yeah, definitely. And I think it's almost been like a thing people have been just trying for decades to sort of like round trip design from diagrams to code and things along those lines. Yeah, I just haven't, I think anything like that, if it depends upon a tool, the question is how long the tool is going to live, whether it's going to go away. The thing that people would be better off doing is basically making sure that whatever they do in that space is renderable by text, right? That there's some way of going and doing, I don't know, it's weird because you tie yourself to the lifetime of the tools that are around to go and basically enable that sort of thing. Yeah, I think it would be nice if you had auto rendering code. They could basically go and sort of like, here's a diagram, or tools that will render any code. But the edge cases are always the weird things with that. I've seen a number of tools that claim to be able to create diagrams for you, but they can never quite lay them out the way you want to. So it has to be like this thing where a human kind of guides where you move things around and stuff like that. I think we're always going to have a tool space around that, but it's because of the lifetime of the tools, it's probably going to be not going to be something where it just takes over the industry, as far as I know. Yeah, who knows? Maybe machine learning might get us into something like that.
Yeah, like for example, take Rust. They designed the language in a very modern way, and they implemented many interesting things there. But they didn't implement, for example, invariants. So you cannot write code and invariants when you define preconditions, postconditions. They don't have that, or they don't have any design restrictions in the code. So you cannot just say, this module is not supposed to be called by that module, never. And
yeah, interesting. I'm glad you brought that up because I hadn't really thought about that, because I did spend some time thinking about that a couple of years ago, but I don't really know what the space is around tooling like that. But I'd love to see more architectural constraint languages. Where, and I really don't know what the state of tooling is. I can only assume it's more advanced with that, but it seems like, it'd be easy to go and have some checks where you basically say, okay, if there's ever dependency of this upon this, then that halts the build, right? That kind of thing. And I've seen people do sort of simple things to go and basically do that, but I haven't really worked with a team that's using a full-fledged system around that. I think that space has got a lot of potential,
They have languages for this, for example, OCL or something, object constraint language.
Yeah, object constraint language was tied into UML, right? And I think there's something around architecture now. I think what's fascinating to me is it seems like there's an interesting space in programming language design where you have there's an abstraction level that people just don't really ever get to, right? So if you think about like in Java, the module system came way later, but there was no concept of what modules were, and then you had the simple thing of like files and class paths and stuff like that, right? And most every other language kind of like, once you get past the file level, it starts to, the language doesn't take files into account, for instance. And it doesn't really talk about bigger structures like components or services and stuff on those lines. And, it's understandable because there's a lot of variation in that space, and a lot of it really, you don't want to basically like set a stake in the ground for something like this and then basically have the technology drift away from where that's actually useful. But it is a bit of a shame that programming languages aren't in that space, because, with type systems, we can do an awful lot more,
I like the thing I got from your blog. You call it honest code, where you, as you explained, that the code has to tell us everything about what it does in a signature. So maybe invariants, they fall into the same category. So if I design the method and I explain in my post conditions, preconditions, honestly explain what the user might expect, then that will be a better code, right?
Yeah, definitely. And I think there's always this, the rough thing for us is that there are many simple, stupid things that work in the industry, right? You can write stupid code and it will be behaviorally correct, but really problematic to look at. And that works, right? So everything that we do beyond the thing of the simple thing, the thing that works, is seen as an extra cost in a way, right? So that's a bit of a problem, right? And that's, it's like the hot dog at the airport sells, right? People will eat that hot dog, right? So I think that, that may sound like a pessimistic view of things, but I think one thing I can share though is that I've worked with people in very critical domains. I used to work with people in life critical, but like financially critical, things where people are going to lose millions of dollars or something like that. And they spend an incredible amount of time with model checking and various different things to kind of like make sure of the correctness of the thing they're doing and the maintainability because of how critical that software is. And so it's doable. We have all the tools to go and do things like that. It's a question of whether the problems themselves are warrant those tools, whether they really need those particular tools. Because in a way, it really is a bit of a cost trade-off. If you're doing something which isn't terribly critical, but you're thinking about those particular tools, you might find a simpler way of getting what you need that doesn't require training people up in a very high performance language or a very, type centric language, for instance,
My last question. Could you tell us a bit about your next book, Brutal Refactoring?
I can tell you that one doesn't exist. Okay. There's a very funny thing about this because on Amazon, somebody basically put up like a placeholder for a book called Brutal Refactoring. And the only thing I can really imagine is that there was a course I did on that in Chicago many, many years ago. And somebody must have just like taken the outline of this and said, this is an upcoming book, right? So that one isn't really existing. There's a thing I've got on the back burner, which is really a book I call Unconditional Code, which is about removing conditionality from systems. It's not just code, it's also just basically like eliminating decision points in order to go and make things easier to go and understand. That's really kind of on the back burner. I've got other things that I'm doing, but for people who are interested in that topic, there are some videos on YouTube. I think I've got one from the GoTo conference in Chicago on unconditional code that many people have enjoyed, and I think that covers a lot of the main ideas.
What does it mean, unconditional code?
Code without conditions. Like conditionality, like if statements, else statements, things like this, right? And it's kind of like you can look at this and expand the concept to just about any place where you make decisions, and it even extends into the user interface in a way. It's like if somebody's going and asking you for something, the worst thing you can do is basically go and say, hey, I need more information from you, or the thing you just gave me as input is wrong, right? I mean, as developers, we're used to having compilers tell us that what we're writing is wrong, right? But users don't like to see that sort of thing. So it's that thing of like, can you actually go ahead and design in such a way that that you don't push work onto the user? And you can do that. A parallel problem with that is when you are writing code, it's kind of like, can we basically write code in a way where we're not forcing extra understanding need on the users of it? We're not going and adding all these conditions which make it hard for us to mentally model what's really happening in the system. And some things are very simple. They're things like using select statements and and filters rather than if statements in different cases. A lot of the things that we kind of call like railroad-oriented programming, where it's like operation, and you remove all the explicit conditionality. A lot of those things make code easier to understand. So it's things in that space. So.
Yeah, sounds interesting. Okay, so we're looking forward to the book, no matter when, but we
yeah,
want to see it.
Fair enough.
Okay, thank you very much. I think I asked all the questions I wanted.
Cool. Well, thank you very much. Thanks for having me on. Okay.
Yeah.
Take care.
Bye-bye. Bye-bye.
Bye.